Did you know octopuses have 3 hearts? Beneath the shimmering surface of the ocean, where sunlight fades into deep blue shadow, lives one of nature's most extraordinary architects, the octopus. With its fluid grace, uncanny intelligence, and alien-like appearance, the octopus seems almost otherworldly, and its anatomy only deepens that mystery. Among its most remarkable features, it doesn't just have 1 heart, it has 3. 2 of these hearts are known as branchial hearts, and their sole purpose is to pump blood to the octopus's gills. Every time the octopus draws in seawater to extract oxygen, these 2 hearts work in tandem, pushing deoxygenated blood through the delicate gill tissues where it's recharged with life-giving oxygen. But here's the twist. These hearts stop beating when the octopus swims. That's one reason why octopuses often prefer crawling along the seafloor. It's less taxing on their circulatory system. The 3rd heart, the systemic heart, is the main pump. It takes the freshly oxygenated blood from the gills and sends it coursing through the rest of the body, powering the brain, the arms lined with suction cups, and even the ink sac used for dramatic escapes. Yet, this heart is surprisingly delicate. During periods of intense activity, like a frantic swim away from a predator, it can become overwhelmed, which is another reason octopuses favor stealth and camouflage over speed. Even in death, the octopus's hearts tell a story of evolutionary ingenuity. Their blood is blue, thanks to a copper-based molecule called hemocyanin, less efficient than our iron-based hemoglobin at carrying oxygen, but far better suited to cold, low-oxygen ocean depths. So, the next time you picture an octopus drifting through coral reefs or solving a puzzle in an aquarium tank, remember, it's not just smart and agile, it's powered by a trio of hearts, each playing its part in a beautifully orchestrated dance of survival in the deep. Did you know there's a tree that bleeds blood? Deep in the arid landscapes of Socotra, an island adrift in the Indian Ocean, like a forgotten myth, stands a tree so strange it seems conjured from legend. Towering yet squat, with a crown shaped like an upside-down umbrella, the dragon's blood tree, Dracaena cinnabari, doesn't just grow, it bleeds. But this is no ordinary sap. When its bark is cut or wounded, the tree exudes a rich crimson resin so vivid it looks uncannily like blood. For centuries, travelers, traders, and alchemists believed it was the very ichor of dragons, hence the name. Ancient Romans prized it as a dye, medicine, and even an ingredient in toothpaste. Medieval healers used it to treat wounds, fevers, and digestive ailments. Artists mixed it into varnishes and paints, calling it dragon's blood, with both reverence and awe. The resin glistens like rubies when fresh, slowly darkening to a deep garnet as it hardens. Chemically, it's packed with compounds like dracorubin and flavonoids, giving it antioxidant and antimicrobial properties. Modern science now confirming what traditional healers long suspected. Yet the tree's blood is more than a curiosity, it's a lifeline. In the harsh, sun-scorched highlands of Socotra, where rainfall is scarce and soil thin, the dragon's blood tree has evolved a brilliant survival strategy. Its dense, umbrella-like canopy channels precious dew and mist down its branches toward its roots, while the resin seals wounds against infection and insect infestation. Every drop of that crimson ooze is a shield, a sealant, a silent plea to endure. Today, climate change and human encroachment threaten this ancient species, but the tree still stands stoic, bleeding red in a land of dust and stone, like a sentinel from a time when magic and nature were one and the same. And if you listen closely beneath its canopy, you might just hear the whisper of dragons, or perhaps the quiet pulse of life itself. Sen, did you know lightning strikes Earth 100 times every second? High above our heads, in the churning bellies of thunderstorms that roll across continents and oceans, an invisible war rages between positive and negative charges. And in the blink of an eye, faster than a heartbeat, the sky tears open. A jagged lance of white-hot plasma plunges toward the ground. Lightning has struck again. Now, multiply that single flash by 100 every second. That's right. While you read this sentence, lightning has already shattered the sky 100 times over. Over the course of a minute, 6,000 strikes. In an hour, more than 360,000. Day and night, rain or shine, somewhere on Earth, the planet crackles with raw electrical energy, roughly 8 million strikes every day. Most of these bolts never touch human eyes. They flicker over remote rainforests in the Congo Basin, arc silently above the empty Southern Ocean, or split the sky above the Great Plains of the Americas. Some never even reach the ground. They dance between clouds in luminous, branching displays known as intra-cloud lightning, illuminating the storm from within like a ghostly lantern. But when lightning does strike Earth, it does so with terrifying power. A single bolt can heat the air around it to 50,000 degrees Fahrenheit, hotter than the surface of the sun, and carry over 100 million volts of electricity. Yet, paradoxically, this destructive force also sustains life. Lightning helps fertilize the soil by breaking apart nitrogen molecules in the atmosphere, allowing them to combine with oxygen and rain down as nitrates, nature's own fertilizer, essential for plants to grow. For millennia, humans have feared and worshipped. Lightning Zeus hurled it from Olympus, Thor wielded it in his hammer, and Shango, the Yoruba god, spoke justice through its flash. Today, we understand its science, yet it still commands awe. Every strike is a reminder that Earth is not a passive rock drifting in space, but a living, electric planet pulsing with energy, chaos, and creation. So the next time a storm rolls in and the sky flashes white, remember, you've just witnessed one heartbeat in a global rhythm of light and fire, 100 times a second, without pause. Since long before we walked upright, and likely long after we're gone,